Welcome back. So in the previous tutorial we've been doing the conditional if statement. So let's go ahead and make something meaningful out of it. Let's go ahead and change this part and say if A is greater than B, I would like you to output I would like you to output that A is greater than B. So let's do it like this. B is B is greater than A is greater than B, and if they're not, then I can write something here, but look, we have three possibilities and we only have two conditions here. We have three possible cases here, but we've only covered basically two of them, although the last statement covers pretty much all of them. How does this make sense? Well, if A is greater than B, this will be printed out. Any other case, the machine will immediately jump to the else statement and execute whatever is in the else statement. However, if I would like to write here, A is less than B, how would I specify a case where A is equal to B? Well, I could type in else if A is equal to B and insert it in between. You can have as many else ifs as you like, so you can cover pretty much an infinite amount of cases. Cout A is equal to B. Okay, so now we have three cases. Let's go ahead and combine this with user input. You can type in, this is my name for the previous tutorial. Let's go ahead and type in cout, enter value for A, colon here, cin A, and then cout, let's tell the user to enter a value for B. Enter value for B, semicolon here, cin B. There we go. So this will run once, and let's go ahead and do this. Compile with Control F11. Okay, so enter value for A. Let's say that A will be 1. Enter value for B. B will be 3. So now it should print out that A is less than B. A is less than B. But suppose we wanted to test this multiple times. How would we do it? I mean, this program, it finishes this it pretty much finishes this. So you enter a value, and as soon as the user enters the values, the computer jumps to this portion. It finishes this conditional statement and it executes the proper condition, the condition that evaluates the true. So either A is greater than B, either A is equal to B, or something else. In this particular case, we only have three possibilities, but you could have 100 possibilities, and then if you missed one, else would always cover it, although you need to make that make some sense. Anyway, now we are going to learn about loops. Now we would like to put this in a repetitive loop where things are going to repeat themselves until we tell them to stop. One of the loops which we can use is while loop. So let's go ahead and insert the while loop above this. While. And well, how many times would we like this to repeat? Well, we don't really know, so let's set it to repeat as many times, as long as let's set it in a repetitive cycle, as long as we, the user, tell it to stop. So let's say true, or you could just write 1 here. 1 stands for true and 0 stands for false. So false or true. I don't know, most of the times it's simpler to write false or true, kind of easier to read, but oh well, that's just your preference. Write whatever you like. Whether you want to write 1 or true, completely up to you. And notice that we have to enclose this. Let me just clear the screen a little bit, expand the screen a little bit. So we have to open up a curly bracket and close a curly bracket in order to encompass this piece of code so that it would be inside of the loop. And I'm just going to press a tab so it's a little bit clearer. And we also want the user input to be within the loop. So let's go ahead and place the user input into the loop as well. Okay, so now we have this, and now we have this. We have the user input, and we have a conditional statement down below. Now all that we need is something to terminate. Well, let's say that the negative numbers will terminate. Enter the value for A, or enter -1 to exit. Let's copy this. Let's copy it down below. Oops. Enter the value for A. Okay, there we go. Just put a colon at the end and a space here. Okay, so we can press -1 to exit. And how would we exit? So we would just type in another. We could theoretically type in another else if here, and then type in either that A is equal to -1 or B is equal to -1, and then we would just type in break. Okay, there we go. If you are using else if, or if you are using while loops or something of a kind, the only case where you won't need these curly brackets is when you have a single instruction that is below it, and that's it. If you don't have curly brackets, it will only take into consideration one single instruction, and it will pretty much disregard the loop or this conditional statement. It will disregard the rest. Now, what does break do? Well, try to figure it out. I mean, it's English language. It just breaks out. It breaks out of the loop, and by that I mean it exits the field of this curly bracket, and it's going to jump straight to return 0. So let's go ahead and type in cout, something that tells us that the program is over and done with. Game over. Let's put it like that, shall we? Press enter here. But you see, this would be a very inefficient way to do it. Why? Try to figure it out. Pause the video if you like, but I'm going to go ahead and tell it to you now. You see, if we place the else if statement here, the conditional statement, the program will indeed exit when we press -1. It will execute the break statement, it will exit the loop, and then it will execute this command here, and then it will return a 0. It will be over. The function will end. But look, our condition for exiting we want our condition for exiting the program to be when a user enters -1 for A or when a user enters -1 for B. Since you have the input here, you will first input A, and even if you input -1 for A, it will go and ask you for the input. It will go ahead and ask you to input B. So you have to input b value as well, and then it will jump to the conditional statement and figure out that a is -1 or that b is -1 and will break out of the loop. That's kind of inefficient, because we only need one of these values and we are being forced to type in both of them. Well, a simple solution would be copy this, cut this out here and place it here. So if a is -1, and we can delete this because we don't need it obviously, since we are just evaluating a, and we can place the if underneath b, where we do not require the evaluation of a. Oops. So look, now we input a, and if a is -1, it will break immediately. And then we input b in case a is not equal to -1. So it says cin greater than b, enter b, the user inputs b, and then b gets evaluated. So if b is -1, again, it will break out of the loop and it will end the program. Far more efficient way, since you only need to enter one of them and not both of them to be evaluated, and then and only then, if neither one of them is -1, will we actually execute this portion of the code. Now this is very significant because you do need to pay a little bit of attention. This doesn't have much to do with programming, this just has something to do with general logic of things, to write things in a meaningful way. So why enter both of them and evaluate both of them if we only need one of them to know whether we can proceed with the program or not, or whether we want to proceed with the program or not. So let's go ahead and see how this works. Okay, here we go. Finished. Enter the value for a, or enter -1 to exit. So let's go ahead and enter it. Oh, no, not there. Let's go ahead and enter 10. Enter the value for b, or -1 to exit. Let's type in 40. A is less than b. Enter the value. Okay. So what do we need to add? We need to add new lines in order for this to look prettier. So let's type in -1. Game over. It exited successfully. But you see, a is less than b. When it prints out, the loop repeats, and it's kind of ugly. You see, it says here enter the value for a, or enter -1 to exit, but it's right here. There isn't even a space. It's quite ugly. I mean, you can't really differentiate it. So what can we do? Well, we could enter a new line for each one of these C out statements. That would be one way. Sorry, not for these statements. Where is it? Oh, I've deleted it actually. There we go. Control Y is for undo. So you're gonna get used to pressing that. So what I was trying to say is that we could add endl to the end of each of these lines. Endl. We only have 3 of them, so that's a realistic option for us. But is that something that we really want to do? Let's see if we can do something better, because imagine if you had 10,000 of these lines, and to each one of those 10,000 you would have to add endl. Then it really wouldn't be a realistic option, would it now? Rather, instead, we will do this. Endl. It's still not going to be as pretty as we like it to be, but it's should do the job just fine. Control F11. Now we can modify the loop additionally and do some other things for this new line to basically be gone. Or we could, or as I said, we could add them down here. But you always add endl. You always add where you have to do the least work. I suppose it would look prettier if we added them to these down below. But let's just go ahead and see how it works out one more time. So 20, and a is less than b, and this indeed works out. So enter the value again, and or -1 to exit. So let's see if this is true. 10 for A, 10 is less than 20. So A is indeed less than B. These were conditional statements with if and else if plus the while loop. Now in the follow-up tutorial we will do the for loop, but before we do that, let's go ahead and see how the increments work. So if we go ahead and type in here while, so while int I is short for index. That's the naming standard. You can name your variables pretty much whatever you want. There are some naming rules, but you can use any combination of lower and uppercase letters to name your variables. So I'm going to say while int I, because I can declare a variable here as well. I don't need to declare variables at the beginning of the program. I can declare them anywhere I like in the place of my choosing. Be careful, because if you declare variables like this, these variables will only be valid for the duration of the loop and within the loop. Once the loop is over, the variable is gone as well. So while I is less than, and I would like this, I wouldn't like a continuous repeatance. I would just say I would like to repeat this 10 times. If the user can't figure it out, if the user can't find it useful in 10 times, oh well, then just terminate anyway. So I is less than 10. And at the end of the loop, so you see what I'm doing here. The condition is, well, the integer I is less than 10. But can anybody see anything wrong with this? We haven't assigned a value to I, and that can be problematic. Why? Well, because I has some random value at the moment, and some garbage value. That's a proper word, proper explanation for it. And that garbage value could be pretty much anything. So let's go ahead and take this out of here, as this is not good for us. And let's declare it outside of the loop. This is just one way to do it. And let's say that I is equal to 0. And then type in here I is less than 10. Now this has sense. And at the end of the loop, at the very end of the loop, we can type in I plus plus. Now what does this mean? I plus plus. Well, I plus plus, let me just show you. It would be the same as me typing in I equals I plus 1. So that's it. Instead of me typing in this whole line plus 1, I can just type in I plus plus, and that would iterate by 1. I could have also typed in I equals I plus 1, but this is a shorter version, and this is pretty much what everybody uses. So what's going to happen here? I is going to become bigger by 1 every time this loop repeats. So in the beginning I will be 0. First pass. A second pass it will be 1, and third pass, fourth pass, it will always increase by 1 until this statement evaluates to false, basically until when I reaches 10, when I becomes 10, this statement will become false because I will no longer be less than 10. You can also put equal sign here. So this will say it is either equal or less than, and in that case this statement would become false when I would reach 11. So we can just leave it like this. But let's not use 10, let's use a lower number for the sake of the tutorial, so I can just show you the repeatance cycle. And now we could basically add more if statements if you would like, and that would basically say, okay, print out NL only if this is not the first repeatance. If it's the first repeatance, don't print NL. And then we wouldn't have this gap here. I would encourage you to do that on your own, just to eliminate this by adding another if statement here, by adding another if statement somewhere in this area.